Hey guys, so today we are starting our next unit. It's going to deal with identities, and we are going to start with 5.1, which is some of our fundamental identities. Some of these you have seen before, and some of them we are going to look at are new. So the first one are the reciprocal identities. Those you have seen before. So remember, cotangent is 1 over tangent, secant is 1 over cosine, and cosecant is 1 over sine. We also have our quotient identities. So tangent is sine over cosine. We've looked at that one before as well. And then cotangent is cosine over sine. So remember, if cotangent is 1 over tangent, we can just flip the sine over cosine to cosine over sine to get our cotangent. We've also got our Pythagorean identities. We've looked at these a little bit. The most common one is the sine squared plus cosine squared is equal to 1. You've also got tangent squared plus 1 is equal to secant squared. And we've got cotangent squared plus 1 is equal to cosecant squared. And then we have our even and odd identities. So some of our functions are even functions, some of them are odd functions, and based off of whether or not they are even or odd, tells us what happens when we plug in negative theta into our function. So sine, cosecant, tangent, and cotangent, when you plug in a negative theta, you get the negative version of that function. Those are our odd functions. Then our even functions are cosine and secant. When you plug in a negative version of that theta, you get the positive version of the function. So cosine and secant are the only ones that are even. Sine, cosecant over here, and tangent and cotangent are both odd. So we're going to use all of these to help us kind of work with some things, and then we'll look at a little bit more in the unit why this is helpful and why we need to know all of this. So first up, it says if tangent of theta is negative 5/3 and theta is in quadrant 2, find each function value. So if we're in quadrant 2, I'm going to do a little bit of side work over here. Quadrant 2 means that we are up here. Here is my theta. And I can use my SOHCAHTOA. If I'm looking at tangent, tangent is opposite over adjacent. So my opposite here is going to be my 5. My adjacent here is going to be my 3. And to figure out which one needs to be negative, we're going in the negative x direction. So this one is the one that has to be negative. We're going to have a negative 3 right there because our x's are negative. Our y's are positive, so the 5 is going to stay positive. I do need to figure out what that c value is in our Pythagorean theorem, or what my hypotenuse is. So I'm going to do a squared plus b squared is equal to c squared. It doesn't really matter which one we pick for a or b, so I'm just going to do negative 3 squared plus 5 squared is equal to c squared. So 9 plus 25 is going to give me 34. So that means that my c is the square root of 34. I can come up here and say that my hypotenuse is the square root of 34. And then I've got my sides, and I can come over here and start filling in these that I have right here. So just to help me out a little bit, I'm going to draw some dividers. We're looking at secant of theta, sine of theta, and then cotangent of negative theta right there. So let's start with our secant. I can come up here and remind myself that secant is 1 over cosine. So if I'm looking at that secant being 1 over cosine, that means that I'm looking at my ka from SOHCAHTOA, and I'm really just switching the ka part of SOHCAHTOA. So secant of theta instead of adjacent over hypotenuse would be my hypotenuse over my adjacent. So looking in my triangle that I have right there, my hypotenuse is that square root of 34. My adjacent is my negative 3. And that's my answer. Sine is using my so. We don't have to flip it, it's just sine, so it's going to be my opposite over my hypotenuse. My opposite is going to be my 5 over my hypotenuse, which is my square root of 34. Hmm. We cannot leave it like that though. We do need to rationalize our denominator. So I'm going to come in and I'm going to multiply top and bottom by that square root of 34. So I'm going to get 5 square root of 34 over 34. And then that doesn't simplify anymore, so that is it. And then I've got cotangent of negative theta. So first thing is I'm going to use my even odd identity that I have right here. Cotangent of negative theta is the same thing as a negative cotangent theta. Do purple. So negative cotangent of theta. And then I'm also going to use my reciprocal identity up here that cotangent is just 1 over tangent. And it already tells me my tangent is negative 5/3. So I'm just going to flip that. This is going to be a negative of negative 3/5. That's going to give me positive 3/5. Because I already know what tangent is. It gave me that in the question. So you can use your SOHCAHTOA to help you, and also use your identities to go through and help you find some values. Some other things that you can do is you can write certain trig values in terms of other trig values. That's what we have like right here in example 2. It says write cosine in terms of tangent. So I want to change this cosine. So let's start with cosine x. And I'm going to look up here at my identities. And the first one that I notice is that cosine goes with secant right here. And then I'm also going to notice that my Pythagorean identity connects secant and tangent. So I'm going to use a combination of that reciprocal identity and that Pythagorean identity to get me to that tangent that I want, because I want cosine and tangent. I'm not going to use the quotient one, even though that does have cosine and tangent in it. It also has sine in it. I don't want sine anywhere in my answer. So I'm just going to use the ones that will get me down to just what I'm looking for. So that's why I'm going to stick with this one that gets me from cosine to secant, and then this one that, even though it's a secant squared, it'll get me to just a tangent squared there. So the first thing I need to know is that cosine is going to equal 1 over secant. Cosine of x is 1 over secant x. That's the reciprocal identity. I'm going to write that over here, reciprocal identity. But then, like I said, we're going to use that Pythagorean identity. But notice the Pythagorean identity has squares in it. So I need to square both sides. Let's square both sides. That's going to give me cosine squared x is equal to 1 over secant squared x. Let's make this reciprocal identity match the color. And then we'll say that we just squared both sides. From here is where I can replace this with that Pythagorean identity that we have right here. So the left side still says cosine squared x, but the right side is now going to be 1 over tangent squared plus 1. So this is using my Pythagorean identity. And then the last thing is that it does say to write cosine x in terms of tangent x. So I do have to get rid of the squared. So let's square root both sides. So when I square root both sides, the square root of 1 is just 1. Well, plus or minus 1. We'll do the plus or minus there. On the bottom, though, we end up with the square root of tangent squared x plus 1. And remember, we can't have square roots in the bottom of our fractions. So we got to clean this up a little bit. So let me copy it over here. What we're going to have to do is we're going to have to come over here and we're going to have to multiply top and bottom by that square root to clean it up. I'm going to multiply the top by that tangent squared x plus 1 and the bottom by that tangent squared x plus 1 and that square root. So I get cosine x is equal to plus or minus the square root of tangent squared x plus 1 on the top. And on the bottom, the square roots cancel and I just get tangent squared x plus 1. And that is our cosine in terms of tangent. All we did there was rationalize the denominator. So I'm writing out what we did in each step, and sometimes in your My Math Lab, it's going to ask you what you do in each step. We do not have to write that out each time. I'm just writing it out so you can kind of see what identities we're using. Because like I said, this unit is going to use identities, which it's going to be really, really helpful that you know all the different identities. And so I'm trying to help you out here by writing what the different identities are that we're using. Great, on the back. You can also use identities to help you simplify the expression so that no quotients appear. If we're looking at this, we've got 1 plus cotangent over 1 minus cosecant. So what we're looking at is, to me, two Pythagorean identities. If I come and look up here, I've got cotangent plus 1 is one of my Pythagorean identities. But if we're looking at the bottom of that, it was 1 minus cosecant, which is the same identity, just kind of jumbled a little bit. So let's rewrite that and see if we can make it match with the bottom. So I'm going to take this identity and I'm going to write it on the back of our notes. So cotangent squared plus 1 is equal to cosecant. Just write it over here. Cotangent squared of theta plus 1 is equal to cosecant squared theta. But I'm trying to make it match the denominator right here. So it looks like I have 1 minus the cosecant, so it would probably help to get the 1 and the cosecant on the same side by subtracting that cosecant over. Sorry. So let's subtract this over. I have cotangent squared plus 1 minus the cosecant squared is equal to 0. And we're trying to get this part. which means we got to move this part over. So 1 minus cosecant squared theta matches with negative cotangent squared theta. So I can say the bottom is negative cotangent squared theta. So sometimes you can use your identities. You just have to be a little bit more clever about how you use your identities. So that's the bottom. The top is the original identity, where it's just the cosecant squared theta. So I can rewrite this as cosecant squared theta over my negative cotangent squared theta. And we've simplified it a little bit. We're still trying to get it so there's no quotients though. So from here, we've gotten rid of the 1 plus and the 1 minus, simplified it down. The next thing that I would look at is my quotient identities, cosecant and cotangent up here. Well, cosecant is 1 over sine, and cotangent is 1 over tangent. I don't know if that 1 over tangent is going to help me. So cosecant, I might still use the 1 over sine, but the cotangent, I might come down here and use this cosine over sine to help me out a little bit. So I'm getting everything in terms of sine and cosine, so then maybe I can see if something will cancel out. So let's use this quotient identity and this reciprocal identity. So cosecant squared would be 1 over sine squared theta, and negative cotangent squared would be negative cosine squared over sine squared, which we've got a fraction over a fraction, which means we can do our keep, change, flip. I'm going to do 1 over sine squared, and I'm going to multiply it by sine squared over negative cosine squared. And that does get the sine squareds to cancel. So now I'm down to a negative 1 over cosine squared. And if we come back up to our reciprocal identities, 1 over cosine is secant, and that gets rid of all of our quotients. We can say that this one was negative secant squared theta. You got to pay attention to what it's asking you for, and sometimes you might go a little bit opposite of that. Notice we ended up getting a fraction within a fraction, which seems kind of counterintuitive to getting no quotients, no fractions. But sometimes you got to go a little bit in the opposite direction to get down to what you're actually looking for. Example 4 just says to simplify the expression. If we're looking at this, we've got 2 parentheses. We've got cosecant minus secant times cosine plus sine. When you got something that looks like this, just like in algebra or trig, we're just going to FOIL it out, multiply it out. So I'm going to do first times first. It's just going to give me cosecant theta times cosine theta. Outside times outside, going to give me cosecant theta times sine theta. Inside times inside, minus secant theta times cosine theta. And last times last is minus secant theta and sine theta. Okay, from here we can still simplify this a little bit. Anytime you see your cosecants, secants, and cotangents, I always try to write them as their reciprocals to see what will simplify or cancel. So we've got a cosecant here and a cosecant here. We've also got a secant here and a secant here. So I can come up here and use my reciprocals. Secant is 1 over cosine, cosecant is 1 over sine. So I'm going to use those to help me out here. So my cosecant is going to change to 1 over sine theta times cosine theta. Same thing here, 1 over sine theta. This time it's times sine theta, so that'll simplify in a minute. Our secants are going to change to 1 over cosine theta times cosine theta will simplify, and minus 1 over cosine theta times sine theta. So right here and right here, simplify. That's going to give me plus 1 and minus 1. We also can simplify this part. It's going to give me a cosine theta over sine theta. And this one is minus sine theta over cosine theta, which if you look at your identities, will be your quotient identities. One of them is tangent and one of them is cotangent. So can come back down here. The plus 1 and minus 1 cancel out super nicely. Cosine over sine is going to give me cotangent theta minus, and then sine over cosine is tangent theta. And our last problem, once again, simplifying. This time, notice we've got a lot of negative thetas there. And so for those negative thetas, we're going to use our even and odd identities. So we've got sine, secant, and cosine. I'm going to come and look at my identities. Sine of negative theta is going to give me negative sine theta. Secant over here, secant of negative theta, just normal secant of theta. And cosine of negative theta is normal cosine of theta. So I'm going to start by simplifying it that way. So everything's going to stay the same, but this is going to come out in front. So it's going to be negative sine theta squared. Secant just makes it positive. So that one's going to stay as a secant squared theta. And cosine just makes it positive. So minus cosine squared theta. For my sine, I am squaring it. So if I have a negative sine theta that I square, that squared right there is just going to become positive. So it's still negative sine squared theta plus secant squared theta minus cosine squared theta. And then anytime you see squareds, sine squared, secant squared, cosine squared, you should start to think about your Pythagorean identities. So if I've got sine, secant, and cosine. So let's see if any of those pair together for a Pythagorean. And if you look, sine squared and cosine do pair together to give me a 1. Sine squared plus cosine squared give me 1. However, I have both of them as negatives. We're going to have to do a little manipulating here. I'm going to first bring them together. So negative sine squared theta minus cosine squared theta. And then I can take that negative out. So negative, and then it would become sine squared theta plus cosine squared theta. So that can give me a negative 1. And I get a negative 1 plus secant squared theta, which come up here is going to work with my middle one right here. Normally we have tangent squared plus 1 is equal to secant squared. But if we move that 1 over, secant squared minus 1 is going to equal tangent squared. So I can say that this negative 1 plus secant squared is tangent squared of theta. So today was kind of getting a little more familiar with our identities. Then we're going to talk about how you can use identities to verify trig equations next class period. So make sure you work on your My Math Lab assignment, and I will see you guys soon. Go ahead and get started on that, and you guys have a good day.